1944. A factory floor in Toronto, Canada. Workers at John Inglis and Company are assembling a pistol that none of them designed, from blueprints that were smuggled, memorized, and rebuilt from scratch. The weapon they are building is identical to one rolling off a production line in Herstal, Belgium at that exact moment, under armed Nazi guard. Same caliber, same mechanism, same 13-round magazine. One version goes to the Waffen-SS, the other goes to British Commandos. At the Battle of Arnhem, soldiers on opposite sides of the line will draw functionally identical pistols and try to kill each other with them. No other firearm in modern history has been manufactured simultaneously for both sides of the same war. This is the Browning High Power. By 1939, the standard British sidearm was the Enfield No. 2 Mark I revolver. It fired 6 rounds of .38 S and W ammunition. Muzzle velocity sat around 600 feet per second. Muzzle energy was roughly 175 foot-pounds. Reloading meant feeding individual cartridges one at a time, because the British Army never adopted speed loaders. The Mark I Star variant, issued to tank crews and most wartime soldiers, had its hammer spur removed and could only fire double action. Troops hated it. According to surviving veteran accounts, many soldiers abandoned the Enfield at the first chance, swapping for American Colts or Webley revolvers scavenged from stores. Britain needed something better. The answer had been sitting in a Belgian factory since 1935, designed by a dead American genius and finished by his Belgian protégé. John Browning filed his patent for a new military pistol on June 28, 1923. He was working for FN Herstal in Belgium, and the French military had specified the requirements. They wanted 10 rounds minimum, weight under 1 kilogram, effective killing range of 50 meters, chambered in 9mm or larger. Browning built 2 prototypes in Utah. The locked breech version held 16 rounds in a double-stack magazine and used a striker firing mechanism. It also contained an innovation that would reshape firearms forever. Instead of the swinging link barrel locking system from his earlier M1911, Browning designed a fixed cam slot machined into the barrel lug. When the slide and barrel recoil together, the cam slot engages a cross pin in the frame and pulls the barrel downward to unlock. Fewer moving parts, more consistent lockup, more reliable under field conditions. Browning never finished the pistol. On November 26, 1926, he collapsed from heart failure at FN's factory in Herstal. He was 71 years old. The man who completed the high power was Dieudonné Saive, a Belgian engineer who had risen from tool designer to Browning's personal assistant. Saive's contributions were so extensive that several firearms historians argue the production high power is more Saive's design than Browning's. His most critical innovation was the double-stack staggered column magazine, which he patented in February 1927. He also converted the pistol from striker-fired to hammer-fired, designed a new trigger mechanism that routed the trigger bar around the magazine well, and reduced the magazine from 16 to 13 rounds to keep the grip slim enough for military hands. FN named the pistol after Browning out of respect for Lemaitre, and because the Browning name carried enormous marketing power. Belgium adopted the pistol in 1935 as the GP35. The designation stands for Grande Puissance, French for high power, referring not to the cartridge but to the magazine capacity. 13 rounds was nearly double what any competing service pistol offered. The finished weapon weighed 915 grams unloaded, measured 118mm in barrel length, and pushed a 9mm parabellum round to 335 meters per second. By May 1940, FN had produced roughly 56,000 high powers. Then Germany invaded Belgium. The FN factory at Herstal was captured virtually intact within 18 days. Nazi managers from Deutsche Waffen- und Munitionsfabriken took control and forced Belgian workers to resume production under a new designation, Pistole 640, letter B. The B stood for Belgisch. The workforce swelled from 4,000 to 12,000, supplemented by forced labourers. Over the next 4 years, the occupied factory produced approximately 319,000 high powers for the German military. The Waffen-SS received the bulk of production. The Fallschirmjäger, German paratroopers, were the second major recipient, valuing the 13-round capacity over the 8 rounds carried by the standard issue P38. Quality declined as the occupation dragged on. Early pistols used pre-war parts and tooling with polished blued finishes. By 1944, late production specimens showed rough machining, inferior steel, and simplified construction. According to unverified but persistent accounts, Belgian workers also sabotaged production through methods like improper heat treatment of components, assembling pistols with broken extractors, and outright theft of parts for the Belgian resistance. At least 14 FN employees were executed by the Nazis during the occupation, which strongly suggests active resistance was occurring and being punished. While the Germans exploited the Belgian factory, the Allies launched their own high-power production through one of the war's most remarkable engineering feats. Saive had escaped occupied Belgium through France, Spain and Portugal, reaching London by mid-1941. He carried no complete set of manufacturing blueprints. What he brought was his memory, his expertise, and drawings for a new rifle design. At the Enfield Design Department, Saive spent months recreating high-power production drawings from memory and from a handful of pre-war sample pistols found in England. The popular legend says a complete set of blueprints was smuggled out of Belgium in a dramatic escape. The truth, according to the Small Arms Defence Journal, is that the smuggled plans travelled slowly through occupied Europe and arrived too late to be of practical use. The contract that actually put the high power into Allied hands came from an unexpected source. In April 1943, Chiang Kai-shek's Chinese nationalist government requested 180,000 pistols through the Canadian Mutual Aid Plan. The contract went to John Inglis and Company in Toronto, a firm that had been manufacturing flour mill machinery since 1859. By 1943, Inglis had transformed into a wartime powerhouse, producing 60% of all Bren light machine guns worldwide. FN licensed the design for a royalty of 25 cents per pistol. Saive and fellow Belgian engineer René Laloux travelled to Toronto to supervise production. Inglis engineers also obtained 6 pre-war FN high powers from a Chinese contract for reverse engineering. Converting all measurements from metric to imperial created significant challenges. The first 4,000 pistols suffered magazine feed problems traced to conversion errors. Now, before we see how this weapon performed in the field, if you are enjoying this deep dive into one of the most extraordinary stories in firearms history, hit subscribe. It takes a second, costs nothing, and helps the channel grow. Right, back to the story. Mass production began in February 1944 and continued until late 1945. Total output reached approximately 151,816 pistols. 2 variants emerged. The Mark I, built for the Chinese contract, featured a tangent rear sight graduated to 500 meters and a slotted backstrap for a detachable wooden shoulder stock. Approximately 66,350 were produced. The Mark I Star, built for Commonwealth forces, carried a fixed rear sight and no stock slot. This was the version that went to war with British and Canadian special operations. The Inglis high power was never general issue. It went to units where 13 rounds of 9mm offered a decisive edge over 6 rounds of .38 from the Enfield revolver. The Special Operations Executive ordered 50,000 pistols, acquiring the first batch in September 1944. Some were produced as sterile weapons, completely unmarked, with no serial numbers or manufacturer stamps, to provide deniability if agents were captured behind enemy lines. The Special Air Service used the high power from their earliest operations. According to regimental accounts, sterile Inglis high powers remained in SAS inventory well into the 1980s. The 6th Airborne Division carried them in significant numbers during Operation Varsity on March 24, 1945, the massive airborne assault across the Rhine. The 1st Canadian Parachute Battalion, attached to the 6th Airborne, participated in this operation. Corporal Frederick Topham earned the Victoria Cross at Varsity, the only member of the battalion to receive it during the war. The supreme irony came at engagements where both sides almost certainly drew the same weapon. At Arnhem in September 1944, British paratroopers of the 1st Airborne Division faced the 9th and 10th SS Panzer Divisions, units that were primary recipients of the pistol 640B. At Varsity 6 months later, the 6th Airborne fought the German 1st Parachute Army, Fallschirmjäger, who also carried high powers. Same gun, same design, different finish. One side parkerized grey from Toronto, the other polished blue from Herstal. Against its German contemporaries, the Inglis high power held a clear advantage. The Luger P08 carried 8 rounds, and its exposed toggle mechanism was notoriously sensitive to dirt. One documented test produced 11 cycling failures. The Walther P38 also held 8 rounds and suffered from slide cracking in some wartime production runs. The high power's 13-round capacity, combined with its robust cam-locking action and tolerance for battlefield filth, made it the superior combat sidearm on any objective measure. The American M1911 fired the heavier .45 ACP cartridge, but held only 7 rounds. The high power nearly doubled that capacity while maintaining a slimmer grip. Doug Wickland, senior curator of the NRA National Firearms Museum, noted that soldiers would continue to face one another with high powers in their hands for decades to come. He was right. The Falklands War of 1982 produced a mirror image of the World War II irony. British officers carried the L9A1, the military designation for the high power. Argentine officers carried their own license-built copy manufactured by Fabricaciones Militares. Same caliber, same magazines, completely interchangeable. The British Army formally adopted the high power as the L9A1 in 1954. Over 50 armies in 93 countries eventually followed. The Canadian Armed Forces set a record no other sidearm can match, using the Inglis high power as their standard pistol from 1944 until 2024, an 80-year service life that exceeded even the M1911's 74 years with the American military. The high power's two core innovations, the cam-locking barrel and the double-stack magazine, became so universal they now define the modern pistol. The SIGP 226 uses a cam lock. The CZ75 uses a cam lock. The Glock 17 uses a cam lock. Every modern double-stack 9mm traces its mechanical lineage to the work of Browning and Saive, a dead man's patent, a Belgian engineer's memory, a Canadian factory that built flour mills. From those ingredients, the Commonwealth produced a pistol so good that even the enemy carried it. FN named it after Browning. History proved it belonged to Saive, and for 80 years the soldiers who carried it into combat simply called it the best sidearm they had ever held.